Addition in exponential notation. Addition is the process of finding the sum of two or more numbers using exponential notation. For example, the sum of a times 10 raised to n and b times 10 raised to n equals to the quantity a plus b times 10 raised to n. The parentheses, open and close parentheses, read as the quantity. The quantity a plus b times 10 raised to the power of n. Example number 4. Find the sum of 6.81 times 10 raised to 5 and 1.04 times 10 raised to 5. Look at the power of your base 10. They are equal or they are the same, which is positive 5. So therefore, we will just get the sum of the two numbers. The quantity 6.81 plus 1.04 times 10 raised to the power of 5. And the sum is equal to 7.85 times 10 raised to the power of 5. That's your final answer. Okay, let's continue. Let's add example letter B. 7.34 times 10 raised to 7 and 4.58 times 10 raised to the power of 7. Look at the power of your base 10. They are the same, which is positive 7. So we will just get the sum of the two numbers equal to the quantity 7.34 plus 4.58 times 10 raised to the power of 7. And the sum of these two is equal to 11.92 times 10 raised to the power of 7. This is not yet our final answer. But why? Can you notice something? 11.92 times 10 raised to 7. If you will say because of the decimal point, maybe you're right, but how or why? Okay, for those who said that 11.92 times 10 raised to 7 is not yet the final answer, you are right. But I will explain to you why. Do you remember last time in understanding the exponential notation? It says there that exponential notation uses the general form of a times 10 raised to the power of n, where your a is a number that is greater than or equal to 1 and a number that is less than 10. 11.92 is greater than 10. So therefore, this is not the general form. Your a must be a number greater than or equal to 1 and less than 10. So therefore, let's have this note. Keep this in your mind that a number written in exponential notation must have only one non-zero digit to the left of its decimal point. So therefore, we will move our decimal point one place to the left. Moving your decimal point one place to the left is the same thing that you are going to divide 11.92 by 10. If you divide 11.92 by 10, the answer must be, or the answer is equal to 1.192. But if you're going to do that, you have to look at the power of your base 10. What will happen to the power of base 10 if you're going to divide 11.92 by 10? Or if you're going to move your decimal point one place to the left? Correct. If you move your decimal point one place to the left, you have to add 1 to the power of your base 10. So therefore, our final answer is equal to 1.192 times 10 raised to the power of 8. Can you follow? Did you get it right? Very good. Steps to add numbers in exponential notation that have different powers of base 10, such as a times 10 raised to n plus b times 10 raised to n plus 1. So here are the steps. Step 1. The power of base number 10 must be the same. A times 10 raised to n can be changed into a over 10 times 10 raised to n plus 1. Step number 2. Find the sum of the number that have the same power of base number 10. A times 10 raised to n plus b times 10 raised to n plus 1 equal to a over 10 times 10 raised to n plus 1 plus b times 10 raised to n plus 1 equal to the quantity a over 10 plus b times 10 raised to n plus 1. Example number 5. Find the sum of 6.54 times 10 raised to 5 and 2.93 times 10 raised to 4. Look closely at the power of your base 10. They are not the same. They have different power of base 10. One is 5 and the other one is 4. We know that 4 is less than 5. So that 2.93 must be changed. Here we go. 6.54 times 10 raised to 5 plus 2.93 over 10 or divided by 10 times 10 raised to 5. By dividing 2.93 by 10 or by 10 is simply same as moving a decimal point one place to the left. If you divide this number by 10, you have to add 1 to your power. Or if you're going to move one place to the left of that number, you have to add 1 to your power of your base 10. Okay? 6.54 plus 2.93 divided by 10 or 6.54 plus 0.293 is equal to 6.833 times 10 raised to 5. And that is our final answer. Let's continue. Example letter B. Find the sum of 9.49 times 10 raised to 5 and 8.9 times 10 raised to 4. They have different power of base 10. There's 5 and there's 4. So we have to find which is lesser power. Okay? So we know that 4 is less than 5. That's why 8.9 must be changed. Okay? 9.49 times 10 raised to 5 plus 0.89 times 10 raised to 5. How it came like this? Why it's now 0.89? As I've said, 8.9 must be changed since it has the lesser power of base 10. which is 4. The other one is 5. Okay, so we have to divide 8.9 by 10. So we can move the decimal point one place to the left, and we can add 1 to the power. That's why it became 0.89 equal to 10.38 times 10 raised to 5. But this is not yet our final answer, because the general rule of exponential notation is your a must be a number that is greater than or equal to 1 and less than 10. Since 10.38 is greater than 10, therefore, we have to move our decimal point to the left one place. Okay? By dividing it by 10. If you're going to divide 10.38 by 10, it will give you 1.038. But what will happen to the power of 5? What will happen? Okay, correct. Since we're going to divide 10.38 by 10, we have to add 1 to your power 5. Because it's the same thing. If we're going to divide 10.38 by 10, the answer must be 1.038, or just moving one place to the left, adding 1 to the power of 5. So therefore, our final answer is 1.038 times 10 raised to the power of 6. Subtraction in exponential notation is the process of finding the difference between two numbers using exponential notation. For subtraction of numbers in exponential notation that have the same power of base number 10, a times 10 raised to n minus b times 10 raised to n is equal to the quantity a minus b times 10 raised to n. Let's have example number 6. Find the difference between 9.63 times 10 raised to 6 and 1.09 times 10 raised to 6. Look at the power of your base 10. They are the same. So, we will just get the difference between 9.63 and 1.09. That is the quantity 9.63 minus 1.09 times 10 raised to 6. And the difference between these two numbers is 8.54 times 10 raised to 6. And that is our final answer. Let's continue. Letter B. Find the difference between 8.67 times 10 raised to 4 and 7.88 times 10 raised to 4. They have the same power of base 10, which is positive 4. So let's just get the difference between 8.67 and 7.88. And that is equal to the quantity 8.67 minus 7.88 times 10 raised to 4. And the difference between these two numbers is 0.79 times 10 raised to 4. But 0.79 times 10 raised to 4 is not yet our final answer. We have to simplify, because it doesn't follow the general rule in writing exponential notation. Okay, remember this note, that a number written in exponential notation must only have one non-zero digit to the left of its decimal point, meaning a number must be greater than or equal to 1 and less than 10. Since 0.79 is a number that is less than 1, therefore, this is not the general form. So what are we going to do now? Okay, we need to move our decimal point one place to the right. By moving your decimal point to the right one place, we have to subtract 1 to our power of base 10. By multiplying 0.79 into 10, you will get 7.9. Okay? So therefore, multiplying 0.79 by 10 is the same thing. You're moving your decimal point to the right by 1. Okay? And subtracting 1 to your power of base 10. So therefore, our final answer is 7.9 times 10 raised to 3. Okay? Good. And that's our final answer. It follows a general rule now. Okay? Your A is a number that is greater than or equal to 1 and less than 10. Steps to subtract numbers in exponential notation that have different powers of base 10, such as a times 10 raised to n plus 1 minus b times 10 raised to n. Step 1. The power of base number 10 must be the same. B times 10 raised to n can be changed into b over 10 times 10 raised to the power of n plus 1. Step number 2. Find the difference between the numbers that have the same power of base number 10. For example, a times 10 raised to n plus 1 minus b times 10 raised to n equal to a times 10 raised to n plus 1 minus b over 10 times 10 raised to n plus 1 equal to the quantity a minus b over 10 times 10 raised to the power of n plus 1. Let's take this example number 7. Find the difference between 7.6 times 10 raised to 5 and 8.7 times 10 raised to 4. Look at the power of your base 10. They have a different powers. Okay? 7.6 has a power of 5 and 8.7 has a power of 4. Since 4 is less than 5, we need to change 8.7. Okay? So that would be 7.6 times 10 raised to 5 minus 0.87 times 10 raised to 5. Maybe you're thinking or you're asking why it became 0.87 times 10 raised to 5. We changed 8.7 times 10 raised to 4 so that they will have the same power of base 10, which is 5. We divided 8.7 by 10 and we add 1 to the power of your base 10. Remember, when you divide a number by 10, this is the same thing as moving your decimal point to the left one place. Okay? Let's continue. That is equal to the quantity 7.6 minus 0.87 times 10 raised to 5. since they have the same power of base 10 now. So we'll just get the difference between the two. And the difference between these two numbers is 6.73 times 10 raised to 5. And that is our final answer. Let's continue letter B. Find the difference between 1.21 times 10 raised to 7 and 6.2 times 10 raised to 6. They have different power of base 10, 7 and 6. So, since we know that 6 is less than 7, we need to change 6.2. That is equal to 1.21 times 10 raised to 7 minus 0.62 times 10 raised to 7. And that is equal to the quantity 1.21 minus 0.62 times 10 raised to 7. And the difference between these two numbers is 0.59 times 10 raised to 7. We need to simplify our answer because 0.59 times 10 raised to 7 doesn't follow the general rule in writing exponential notation. So we need to move our decimal point one place to the right direction. Okay, to the right. By moving your decimal point one place to the right is the same thing as you are subtracting 1 from your power of base 10. Okay, let's have this note again. In writing the exponential notation, it must have only one non-zero digit to the left of its decimal point. That's what I'm telling you earlier. So therefore, our final answer is 5.9 times 10 raised to 6. For your homework, answer test yourself 1.2 of your textbook on page 7. I will repeat. For your homework, you have to answer test yourself 1.2 of your textbook on page 7. Problems 1 to 5. I hope you learned something new today. Once again, this is Teacher Dan. Thank you for listening. Have a nice day. Goodbye.